Yeah, right, that works. Just
Yeah.
good. There I am. Okay, good. So I'll just start, right? Can you hear me?
Yes, we can hear you. Yeah.
Good.
Now we can see your slides.
Okay, good, perfect. So welcome everybody. I'm going to talk about the Dutch National Knowledge Graph, which we recently created. Give some background on this. So this was a work from basically the core DVpedia team and also the Dutch partners. I'll have them on extra slides to get them credit because they helped us a lot understanding the Dutch data. First, some background. So why linked data at all? Yeah. So I've in the last 5 years, I've researched this question intensively. And so the conclusion here, so I really tested it. I looked at other systems and everything. So linked data really forms the largest knowledge graph on Earth. And the cool thing about, or the thing that convinced me is that there's really no alternative to connect all this data. So many other of these data paradigms, they just cannot do this. Yeah. So there's no alternative technology in this sense, and this is the conclusion I came within my research. It is not an easy paradigm in a sense that the data is constantly changing. Yeah, so it's constantly updated, and it's also decentral, which makes it complex in the end. But then I didn't find any alternative solution to it. So that is the main reason why linked data is great in the end. Yeah. I also thought about knowledge graphs a lot, and it seems that you can consider it the fourth factor of production. So if you know about economics a bit, so you have land, labor, capital, and then there's this fourth factor, which is not really known, but it is clear that if you have more know-how, more knowledge, then you are more productive. And here I see a great role for knowledge graphs. Yeah, not as a thing, why do I need it, but as a real factor of production, which is kind of like ingrained into the core of economics. Also note, and Peter Mooney mentioned this as well, this is not AI or machine learning. So according to Mitchell, machine learning needs experience. So you need to feed experience to the machine learning algorithm. And this, in my idea, is also knowledge. Yeah. So if you don't have a knowledge graph and you don't have the knowledge, then your AI will work mediocre in a sense. So it is a very essential thing that we're doing. And I think we should get some of the glamour of the AI sector also for this, yeah, because they also always boast that they did something great, but in the end, it's also knowledge engineering behind the AI that drives it. So I talked about complexity and about how this can be handled. So, and there's this big what if, yeah. So what if we had kind of like a GPS to tell us where exactly to get the part of the graph, of this large knowledge graph that we need, yeah? And what if we could access it as one graph, yeah? These are the two core questions, which I'm hopefully going to answer in detail in this presentation. And here I'm talking about a GPS because this is kind of like a geo conference, geo-linked data conference, but later I could also call it DNS, similar to the DNS in the internet. You know? So what we are building now is linked data derived knowledge graphs. Yeah, so you want to take out a part of this huge linked data cloud that you need. So on the left side, you have linked data as the largest knowledge graph on Earth. So, yeah, right. So you have linked data as the largest knowledge graph on Earth, and you kind of like identify a linked data subcommunity. So basically, you scope it in a way what you want to have. Yeah. And then what you can do is you can crystallize it around DBpedia. And I'm not talking about the 6 million old identifiers or the language chapters. I'm talking about the new global IDs and the knowledge library. Now, this is not something that we are doing for the first time now. We did it the same in 2008 when the LOT linked data cloud crystallized around DBpedia. And now we just extend the identifier space further. So what is our new initiative? So we have this initiative to create 1 billion of these linked data derived knowledge graphs until 2025. And yes, 1 billion sounds like a lot, but then basically you need another knowledge graph for each day or for each use case. Yeah, you need another one. So 1 billion is actually quite realistic for all the IT applications that you have. And then here let's look at one linked data derived graph, which is the Dutch National Knowledge Graph. So how's the Dutch National Knowledge Graph designed? It's a digital twin of a country. So on the left, you see the Netherlands, and it's people, culture, geography, and economy. So this is basically the real world. And then you have this national knowledge graph, which is a fused, coarse-grained knowledge graph to discover links to authoritative and other data sets in the scope of the nation. So it connects the data sources from a country. And how we're going to build it is we are going to make a DBpedia-style crystallization point to connect this national data in a national knowledge graph. What did we use as input? And here I put the logos of our Dutch partners on the left side. So these are all authoritative data sets for the core using global ID. So on top, there's RCE and RKD. Then there's the KB National Library. And then on the bottom is Cadastre. I think you all know Erwin Vollmer, who was also part of this project. And then we used other data sets with similar topics for enrichment. So there's the DBLP, which is a citation database from Germany, and also the Dutch DBpedia, extracted from the Dutch Wikipedia. Oh. Yeah,
Do you stop it?
No, it stopped itself.
Oh, no, it's starting again. Yeah.
Yeah, I started it again. Okay, and then so on the right side, we integrated a lot of links from the German National Library, Wikidata, Diffbot, Music Branch, Geonames, ORCID, a lot more actually. And these are kind of like the three inputs for this knowledge graph. Here, I would like to acknowledge the work done by my colleagues, Enno Myers, Wouter Beek from Tripoli, Pano Maria, Erwin Vollmer from Cadastre, Jesse DeVos, Victor de Boer, and then my team. And also thanks to two representatives from RCE and RKD. So what was the work done to get this knowledge graph derived from linked data? So we asked for dumps of all participating data sets. This is something we need kind of like a global state of the data set to assign these global IDs for it. And we started adding mappings to the knowledge library. So this means all equivalent properties to the DBpedia ontologies. And then we do Sparkle construct to map complex structures to simpler DBpedia properties. I included the link for these queries here there on GitHub. And an example here is Cadastre has building data and uses polygons to identify these buildings. But for a coarse-grained database, if you just want to put points on a map, you need just a point. So this is transformed to latitude and longitude. What you can do, however, here's a breakdown of the Sparkle endpoint, where this is hosted at the moment. And on the right side, you can see the class makeup. Yeah, so you have 7.5 million buildings which come from Cadastre. So the way this is traced back is that you can access the national knowledge graph, get all buildings, get all links to Cadastre, and then go to Cadastre and get the polygons via linked data. So this is the pattern that this knowledge graph uses, right? So in itself, it provides a rough orientation of what data is there, yeah? And then if you want to have the accurate data, you need to find the links and go to the respective linked data source. Another thing is that we have 5.5 million persons from KGiA mixed in with DBpedia and DBLP a bit. And then there's 250,000 artists from the RKD dataset and 75,000 monuments from RCE, which are also linked to the cadastre buildings. So this is a subclass relation. Total, there are 18 million entities, which compared to Dutch DBpedia, which is like 9 times as much. This had only 2 million, 302 million facts, and then 45 million outgoing links. I'll show you something about how you download it. So this is the way you query it and find more links. And then here's the downloading and the tailoring. So this is kept on the data bus. It provides an additional paradigm to query by identifier. Yeah, so linked data can be queried by identifier. But here, if you just want the birthplace or the birth date, let's choose the birthplace and the birth date. Then you can query the individual files by properties. Here, they use global IDs as subjects and birth DBpedia ontology as properties and this as well. And in this way, you can freely combine a new knowledge graph, kind of like from these property partitions. Yeah? So this is a new way of querying linked data via this national knowledge graphs. Another technology here is cartridges. So these correspond to bubbles in the lot cloud. And here, so we build all these cartridges of the individual data sets. And these are also freely combinable. It means if you don't care about persons or authors, you would take the cadastre cartridge and the CHO cartridge, which has the monuments, and maybe you select the geonames cartridge. And then you just get a graph that is focused on geo information and buildings. Yeah, so this is how the flexibility, how you can derive knowledge graphs from LOT via this approach. Another great achievement here is with something I call accuracy versus size. So of course you can measure size, yeah, who has the most facts or whatever. Okay, it's good to measure, yeah. You cannot measure accuracy so well, but overall, these authoritative data sets are important because they provide an accurate view of the world. So they are kind of like normative also in the sense that they create reality. Yeah, so if cadastre says this is a building and this not, then this is the truth of the world. So there comes a whole sense of accuracy in the game, and also into the identifiers used by cadastre. So here's an example. Anne Frank House has one Wikipedia article, and this is okay because the definition of an encyclopedia is that it is a summary of knowledge. Yeah, so they put things together in a sense that they summarize a topic well. Yeah, but this is not. It loses kind of like the accuracy. And then there are 2 building identifiers in cadastre for the Anne Frank House, and this is accurately because it's 2 separate buildings. Yeah. It is also written somewhere as a side note in the Wikipedia article, okay. But in reality, it's 2 buildings. And then what is the expectation for these new national knowledge graphs? They will have an unprecedented accurate data. So they will tell you how many companies are in a nation, how many buildings, how many streets, important persons, yeah, from the libraries, the authors, the artists, paintings, everything. So very accurate if you fuse this together and build a linked data backbone on it. So what are benefits for linked data providers here? You have the possibility to improve data quality by data comparison. So this is the concept of the data washing machine or working lot laundromat, if you still remember this project. And I'll show you one here. So this is a person, Neskio or Krönlo. Yeah. You will see that you can compare the dates between different databases. It also is a system that will eventually guarantee 100% integration into the linked data cloud. So now I'll wrap up, Erwin, real quick. So benefits for consumers. We made this chart to show kind of like a new order of size here. So This compares selected knowledge graphs, open and closed, by number of entities they described on a log scale. Yeah, and you can see here that there's the DBpedia EN, which we call tiny now, and then there's the Dutch national graph, then there's Wikidata, still a bit larger, but then it's kind of like between the DBpedia tiny and small diamond, we call them now, because they are compressed out of other data sets. And then you have this largest diamond, which already has half the size of Google. And then comes Google, and Diffbot is also a magnitude larger, and then the linked open data cloud is much, much higher. Do I have to wrap up, Evan?
You really do have to wrap up.
Sorry. So what will it change? The current question is, where do I get data? So this is what most people ask, where can I get data? And the new question is, how much data do I need currently? Yeah, so it's an ad hoc system to retrieve the information that you currently need. And then, so what can we do in the future? Integrate your data into this DBpedia linked data GPS, and become a member of the DBpedia Association to help us restructure the linked data cloud. Sorry for doing the overtime, Evan.
Okay, well, thank you, Sebastian, and really thank you also for starting this initiative. I find this really interesting, and for me also, it's a new way of combining more the community kind of data with more authoritative data, and that's, in my opinion, is very challenging for the future. We do have some questions in the chat, but maybe you can answer them in the chat directly. I did also have some question more about the future perspective, because we're now covering only just a small set of Dutch data sets, and there's even much more data sets. So I'm really looking forward to how this can work out in the future, and we can add more data connectors, more data bus connectors to the data, and